All right. Okay, next slide, please. As we kick off the conversation, I am going to ground us in what LA Metro is. For those that don't know, and if you're not a regular rider, we're a transportation planner, a designer, builder, and we operate the public transit system for Los Angeles County. That is 1,400 square miles of service area. That is for 10 million people, and we service the 88 municipalities and the over 140 unincorporated areas in Los Angeles County. Next slide. We are a massive transit system. As you see, the third busiest. We have bus, rail, and next slide. A system that is only growing. We actually have the largest capital program within North America. That is a building program where we are growing not only our rail lines, but also our bus rapid transit to improve service for our customers and ultimately quality of life for Los Angelinos through access. Next slide. And Metro Art, since Metro's inception, we have been integrating site-specific artwork into all of our stations and public-facing facilities. We also, next slide, curate programming, temporary exhibitions. Our guiding principles are to put people first in all that we do. Next slide. To connect to creative communities throughout LA County, acknowledging that Los Angeles is full of communities that are distinct and culturally rich. Next slide. And we champion innovation in the way that we integrate artwork, both through the artists that we bring on for these commissions and opportunities, but also through the materials, thinking about longevity and diversity of those finishes, including this piece along the gold line, now the L. Next slide. And to ground us with the Regional Connector Project, which Mungo Thomson, who is leading this talk today, has been commissioned to create a site-specific artwork for. The Regional Connector brings 3 new downtown stations to our system. It is actually closing an existing gap in our system. For any of you who travel from the Gold Line L, maybe down to the A line Long Beach, or from the East LA Gold Line to the E line Expo line, you have to make 1 or 2 transfers. This will allow you to have an uninterrupted ride from East LA to the beach, to Santa Monica, and an uninterrupted ride from, say, Azusa on that Gold L line, all the way down to the A line Blue in Long Beach. So we're thinking that this is going to reduce your commute by approximately 20 minutes, potentially. And just an image of the work that's underway. The Regional Connector's 3 stations will be slated to open before the end of the calendar year. Mungo Thomson, who I have been privileged to work with over the last 7 years almost, has been commissioned to create a work for the Grand Ave Arts Bunker Hill Station, and that is at 2nd and Hope. And without further ado, I'm going to introduce him and read his bio. Mungo Thomson, based in Los Angeles, is a conceptual artist who works in a range of media, from sculpture and photography to video and sound installations. He approaches mass culture and everyday life through a lens of deep time and cosmic scale, embedding vastness in common materials and experiences. Thomson earned a Bachelor's of Arts from the University of California, Santa Cruz, and Masters of Fine Art from the University of California, Los Angeles. He participated in the Independent Study Program at the Whitney Museum of American Art and is the recipient of a number of awards. His work has been exhibited internationally and is in the permanent collections of the Hammer Museum, Los Angeles, Hirshhorn Museum, and Sculpture Garden in Washington, D.C., Los Angeles County Museum of Art, Museo Jumex, Mexico City, Museum of Contemporary Art in Los Angeles, Museum of Fine Arts in Houston, Walker Art Center, Minneapolis, and Whitney Museum of American Art in New York, among others. And Mungo, take it away.
Hi, everyone. Thank you for joining us, and thank you, Letitia, and thank you, 𝘕𝘦�dz𝘚, for their support in organizing this talk and the project overall, and to Marty Hudson and Maurice Henderson for being so generous with their time and sharing their expertise with us tonight. By way of brief introduction to my project with the 𝘕𝘦�dz𝘚, I thought I should probably show a little bit of other work to give context and historical framing. I work in a lot of different kinds of media, and in a lot of different sort of threads and production lines. So this is one of them, but I wanted to show you a few others. So yeah, can we see the next image? In general, I would say that my work is concerned with the nature of reality and the way experience is mediated by culture and the lenses and frames through which the world arrives for us and the way we learn to forget to see those frames. So in the past, I've made works that talk about time and space using cultural materials, or that try to embed an idea of the cosmic in everyday things. I've made works that riff on print media and optical perception. I've made works that function as clocks or timekeepers and function as musical instruments, or as permanent geological monuments to transient consumer habits. And I've made works that try to catalog the whole of human activity on film. The particular thread of my work that's relevant for tonight begins in 2006 with the publication of an artist book called Negative Space. And I had already been making works that took popular cultural material and tried to transform or invert it in some way. A good example would be this video work from 2002 called The American Desert, which displays only the backgrounds from Roadrunner cartoons. The coyote and the Roadrunner and all that energy and violence have been removed, and you have this half-hour tour through peaceful cartoon desert landscapes. And as a result of works like this, people began to say I was interested in backgrounds and voids and in negative space, and I decided to take that literally. So I made this book called Negative Space. This was an artist book where I simply downloaded high-resolution images from the Hubble Space Telescope online archive and inverted them in Photoshop and then laid them out in a publication. And I wrapped them all in a cover that references National Geographic, another important frame for me. And this was in some respects a sort of swift, prankish gesture, but I became very taken with the way inverting these images that we all know made them strange and psychedelic and unfamiliar. And I later learned that a lot of early astronomical photography was done using glass negatives because it's easier to pinpoint a black star in a white void than a white star in a black void. And I was interested in the way that this corresponded to, in an odd way, to the exhibition structure in the art field, where the empty gallery space is colloquially known as the white cube. So in the art context, the void is white, not black. And these images became a simple way for me to respond to the default conditions of any exhibition context. I could just wallpaper it with one of these images and align the color of these two voids and make the background, the walls, the foreground, another inversion. And out in the world, in public space, on billboards, they function to negate an advertisement that would otherwise be there, and so on. So I've been making negative space murals since 2006 in museums, galleries, offices, universities, private homes, public spaces, which brings us to the Grand Avenue Arts Bunker Hill station of the 𝘕𝘦�dz𝘚. But first I wanted to take a very short aside. This is a glass negative of a photograph of the Andromeda Galaxy taken by Edwin Hubble using the 100-inch telescope at Mount Wilson Observatory in October of 1923. And this photo changed our understanding of the size of the universe. I think Maurice is going to talk a little more about that topic. And this is a photo that the Hubble Space Telescope took of Andromeda Galaxy in 2015. And this image was the largest Hubble image yet assembled and the sharpest large composite image ever taken of Andromeda. It consists of 7,398 exposures taken over 411 individual pointings of the Hubble, assembled together into a mosaic image. I immediately made this into a negative space image. Please note that when you zoom in on this image, those dots that you see are not pixels, but stars. So in 2016, when I was invited to propose a work for the Grand Avenue Arts Bunker Hill LA Metro Station, I chose to make a negative space mural of the 2015 Hubble Andromeda image, because the image and concept seemed to pair well with the site. The station is itself a negative space or void in the earth, and I liked that rhyme. It also happens to be the deepest station in the LA metro system, meaning I would have the most subterranean work of art in Los Angeles. And I liked that pairing of opposites, putting an astronomical image deep underground. I felt like that would be an unexpected encounter. Further, the sawtooth edge of the mosaic image rhymed with the usual surface subway tiling that you encounter in the subway system, and the points of the stars in the image could be imagined to be dots on a transit map.
Hey, Mungo, just a really quick note.
Yeah.
We're getting a little bit of feedback, maybe when you turn a page or something like that. Just not much.
Okay. In general, I was interested in bringing this notion of cosmic scale into the realm of the everyday, in the realm of public transit, and I wanted to bring a sort of relative notion of travel and distance, these relative notions into proximity, city blocks versus light years. But I was also became interested in the underground location and how it's another kind of distance dug into the rock and further back in geological time, which finally brings us to the subject of tonight's talk, which is underground astronomy. I began thinking about astronomy and geology as the two vectors converging on this site and with this project, and the two very different kinds of machines and kinds of engineering that made it possible, and their similarities and differences. And that is why I invited Marty and Maurice to talk with me tonight about these two machines, one, the Hubble peering out into space, and the tunnel boring machine boring through layers of rock, both looking backward through cosmic and geological time. One is peering up into space, and the other is boring down through layers of rock compressed in the earth. And this was some of the thinking that went into this project. I wanted to try to tease some of it out tonight with a pair of specialists who actually know what they're talking about. And with that, I will introduce them. Marty's going to speak first. Marty Hudson is currently Director of Geotechnical Engineering for the Turner Engineering Group of Turner Construction. Marty previously worked for Wood Amick MacTech, performing geotechnical engineering as part of the preliminary engineering teams that worked on the tunnels and stations of the Regional Connector Project. He has specialized in tunneling excavations, including deep excavations with shoring, foundations, slope stability, and geotechnical earthquake engineering. Dr. Hudson holds a BS in civil engineering and a Master of Science in geotechnical engineering from UCLA and a PhD in geotechnical engineering and transportation planning from UC Davis. He is a registered civil engineer and geotechnical engineer in California. Marty.
Greetings, everyone. So I love the introduction of all of this. And I didn't realize when I was looking into tunneling in the ground that it was such cosmological significance, but it's fascinating to tie it together. So let's talk a little bit about the underground engineering associated with the regional connector. Next slide, please. I'm going to start with this image. This is an image within this station of the regional connector and first focus your gaze on the tunnel at the left. The tunnel that you see open on the left with a string of lights in it, that's the objective. If you're thinking of the whole project in a purely practical manner, it's a tunnel through which trains will transport people. So the objective is to create this tunnel. So with that being the objective, then on the right side of the frame, you see the machine that enables that objective to be accomplished. And for this particular project, Metro named the machine Angeli. So that was the name. Every tunnel boring machine traditionally is given a name, and that was the name of this one going through the heart of Los Angeles. Now, it obviously takes a big machine to drill a tunnel that big. It was manufactured in Germany by Heron Connect. They do a lot of the tunnel boring machines worldwide. It weighs 1,000 tons, just the machine. It's 400 feet long. You realize how long that is. That's in a very long machine to accomplish the tunneling. And in this case, for this tunnel, it was 21.6 feet in diameter. So how well did it chew through the geologic materials? It went about 70 feet every day on average. And so the total distance it went was 10,900 feet between the two tunnels, resulting in almost 250,000 tons of earth that was excavated. Okay, that's what was accomplished. Next slide. So let's talk a little bit about the concept of how it does it. In this picture, you see just the front end. That's not the full 400 feet length of it, but they've taken the front end of it off so you can see that. And modern technology for tunneling, the objective of this machine is to keep the earth pressurized on all sides while the tunneling occurs. It's called an earth pressure balance machine, EPB for short, meaning that the front of the tunnel and the sides are all pushing out with a force equal to the force deep in the ground. And so if you achieve that objective, which is Heron Connect's design of these machines, with that objective, then even a few feet away from the tunnel boring machine, the earth doesn't know a tunnel is being created. The earth doesn't know that a void is being created in its midst. Because if it does know, it could do things like move or other things that you don't associate with good tunneling. So our objective is for nobody to know on the surface tunneling is occurring, and not even a few feet away for the ground to know what is occurring. So that's the concept, the engineering concept of an earth pressure balance machine. Next slide. So then we think about, we've got the objective being the tunnel, the machine Angeli that's going to eat through the earth. What is the material that it's going to dig through? So geologically, we like talking about the time, and we have names for all of these periods of time in the back, going all the way back to the creation of the earth. And the particular material through which most of the regional connector tunnel was built is called the Fernando Formation. That's just the name of that material. How old is the Fernando Formation? It's from the lower Pliocene age. That's where it is. So on the bottom, you see a chart where you can identify the Pliocene, and the chart, as it shows, most recent is at the top, oldest is at the bottom. So this particular chart goes from current day to 23.03 million years old. So this one chart is 23 million years of the Earth's history. So you can see where the Pliocene fits in there. It's somewhere around 2.5 to 5 million years old. So put yourself in the place of that Earth. That Earth was laid down 2.5 to 5 million years ago. And it was part of a long period of time called the Tertiary period that began 64 million years ago, a lot before even the chart started. And the Earth was undergoing a gradual cooling trend that ended in this section with the ice ages. So it was warmer, and then it gradually got colder and colder and colder. But generally, the Pliocene world was warmer than it is at present. So I'm trying to develop a picture so you can imagine the Earth the way it was when that soil was deposited that is now rock. Okay, next slide. So how do we know what the Earth was like? Well, if you excavate in it, then you literally see fossils. And you don't just see any fossils, you see marine fossils throughout the Fernando Formation. And here's an example of Fernando Formation fossils. And you see what you would expect to see in the ocean, a lot of shells from the marine life that was living on the ocean floor. So gathering all of the information from fossils and other information, we get an idea of what the Earth was like. It's hard to conceive how different the Earth was 4 million years ago when that Earth was being placed. First of all, Los Angeles geographically was about where the US-Mexico border is now. So the San Andreas Fault is moving us northward in LA. And so back at that time, it was deposited about where the border is now. So it's moved 140 miles in that time. We know the rainfall was around triple what it is now. So it was wetter. It was warmer, so warmer, wetter, farther south. And then every decade, it was getting slightly cooler on average. So if these are marine fossils, how deep is the water? And for anyone more interested in this, I highly recommend going to an exhibit at the Natural History Museum of Los Angeles right now called Los Angeles Underwater. And it helps you visualize how LA was underwater. So at that location where this Bunker Hills station was, it was under 900 to 4,000 feet of water. Imagine deep enough to cover every skyscraper that currently is there. That's how much water was there. And all these shells were being deposited, etc. About 13,000 years ago, then LA gradually emerged from the ocean. And Palos Verdes emerged from as first an island and then connected to it. So it's a very different place. But simultaneous to all of that, the LA basin was dropping because of tectonic activity, and the San Gabriel and Santa Monica Mountains are going up. So all of the soil is eroding down into the land that we now see at the bottom of the ocean. Next slide, please. So what are the kind of things, now that we know what the geology was like roughly, what are the kind of things you encounter when you're metro and you're tunneling around LA? Not just fossils, you see fascinating things. They even excavated through cemeteries before. The upper image is for the Metro Gold Line project, where they uncovered grave sites. So that's recent history. Then below, you see what you get when you excavate down Wilshire Boulevard for the Metro Purple Line extension. Just like at the La Brea tar pits, you see lots of Pleistocene age animals. So those animals were at a time when LA had emerged from the water, and those are the animals that were living on the ground at that time. And that seems like a long time ago, and it was, but the Bunker Hills station even farther back in time. So next slide. That
And
concludes
oh.
my part.
That was so fascinating, Marty. Thank you. Okay, I'm going to introduce Maurice Henderson. Maurice is a former education and public outreach engineer at NASA. He served as the program manager for NASA's support of the Science on a Sphere visualization platform and the Hubble Space Telescope traveling exhibits based at NASA Goddard in Maryland. He worked with developers at the National Oceanic and Atmospheric Administration and with the NASA science community. Henderson holds a BS in electrical engineering from Tufts University and a Master of Science in Executive Engineering from University of Pennsylvania. Hi, Maurice.
Hello, and thank you very much, LA Metro and Mungo, for inviting me to participate. As a Hubble hugger, I'm always looking for an opportunity to talk about Hubble, and in these wonderful days of the James Webb's unveiling of its first observations, it's very exciting to talk about the Hubble Space Telescope and the ground that it's laid for the future of astronomy. And so I'd like to start with the school bus because it's a good metaphor for me for the Hubble Space Telescope. First of all, it's a good representation of the size of the Hubble Space Telescope. The telescope's about the size and diameter of a school bus. And it performs this function of taking our eyes to far, far reaches of the universe. And so as we travel on our school bus, today we see in the universe this smiling face cosmos, this gravitational lens structure in the image. And you'll notice these two eyes and this white nose, those are galaxies. And the gravitational lensing effect of the smiling that creates this smiling face also shows you a distant galaxy beyond this massive cluster. And so every time we travel through the eyes of Hubble, we see back in time parts of our universe that is just unfolded for us. But let's do a little history in the next slide before we move to the images themselves. And I want to talk about the three people who were most instrumental and important to the foundations of Hubble. First, Dr. Lyman Spitzer proposed in 1946 that we build a space telescope to get above the atmosphere and the distorting effects of the atmosphere so that we could see much better and that we could begin to explore the improvements in telescopes to allow us to push out further and further in the universe. And in 1949, Dr. Nancy Grace Roman joined the new organization of NASA as program director for the astronomy program. And it was her efforts in these early years that shepherded this idea of the space telescope and ultimately gave fruit to the telescope known as the Hubble Space Telescope. And as the telescope came into complete final formation, Dr. Edwin Hubble became the namesake of the telescope. And it was his groundbreaking astronomy in the early 20th century that set us on this course for cosmic exploration. In the 1920s, his work discovered that we were not just the Milky Way galaxy was not the only galaxy in the universe, but it was just one of many galaxies. And Mungo talked earlier about this variable star, this Cepheid variable star in the Andromeda galaxy. And it was this star that allowed Dr. Hubble to determine that it was not a part of the Milky Way, but it was in a different galaxy. And also, he went on to discover that the universe was expanding and to measure that expansion and create what's known as the Hubble constant, which was used by Albert Einstein to complete some of his theories of general relativity. And so these three people represent the foundations upon which modern astronomy has been built. In this next slide, a little bit more history, but nearer is the story of Hubble. And when Hubble was launched in 1990, it was quickly discovered that it had a spherical aberration. And the spherical aberration prevented it from completely focusing on objects. It was built to be an improvable instrument. And in December of 1993, astronauts went to Hubble and serviced it and installed the Wide Field Planetary Camera 2 along with the CoStar to improve its optics. And in January of 94, Hubble delivered this clearer image of M100, much clearer, allowing us to see the center of the galaxy and all its fine and splendid detail. And from there, Hubble went on to show us great things in the universe. And in the next slide, and you can start the video, I just want to talk about Hubble's science very quickly, looking at our solar system, black hole structures, the galaxy structures across the universe, the discovery of dark matter and dark energy, and the questions around cosmic expansion. And I show you these anniversary images from the first 32 years of Hubble to just give you a sense of the art of and beauty of the Hubble observations. And in the next slide, we look at one aspect of this cosmic expansion work as we look deeper, and each servicing mission allowed Hubble to look deeper and deeper into the universe, getting closer and closer to the early years of the universe after the Big Bang. And it is this work that allows our astronomers to better understand the early universe. And we, with Hubble, have been pushing back into the last 500 million years before the Big Bang. And it's hoped that our new James Webb Space Telescope will allow us to push back a few 100 million years closer to the Big Bang and the first light of the universe. In the next slide, we look at some of these deep views of the universe in one spot of the sky, a little smaller than a full moon. And we see galaxies in this deep view across the entire spectrum. There's about 260,000 galaxies in this one little patch of sky. And this is about 16 years of observations that have been made by Hubble, starting with the one in 1995, where we looked for 10 consecutive days. And then there are many other deep views of the universe in this particular spot. So this is the largest history book of the universe that we've collected with Hubble. And as we look at the universe and through the eyes of Hubble, we see really beautiful structures. And I'll just pick my favorites here. So if we can start with the Cat's Eye Nebula. This is a single star, about 3,000 light years from Earth. It's a dying star. About every 1,500 years, it pulses out. And so it creates kind of like a onion structure where these layers of gas are illuminated by the glow of this dying star. And the next image, first taken in 1995, after Hubble had improved eyesight, we see the pillars of creation. And this Eagle Nebula is a beautiful structure where it's kind of the birthplace of stars. And we came back in 2014, and we see that in infrared, we see many, many more stars in the structure for the Eagle Nebula. And the last one I'd like to look at is a story of a solar system in creation. And the Fomalhaut star had about it a dust disk. And when we first saw it, we thought we were looking at the first directly observed exoplanet. But over the years, we've begun to see that it's a dusty disk around the star. And this is these are probably the formative years of a new solar system. The last thing I wanted to do is to let you know that in 2022, Hubble is very healthy, doing extremely well. It's very productive from a science standpoint. And we think that it is at its apex of efficiency and power. And we look for it to complement the James Webb Space Telescope, the WFIRST telescope, and other new NASA observatories for many years to come. So with that, I'd like to thank you for the opportunity to speak to you about the Hubble Space Telescope. Thank you.
Thank you, Maurice. So, yeah, those were both so interesting. If you don't mind, I would like to just open it up to a conversation between the three of us for a few minutes, and then we can open it up to general Q&A. And if you don't mind, I think my questions will probably be a little bit more on the layman and conceptual side, but I'm so curious about both of these trajectories and bringing them together tonight. And maybe a way to frame it is to say that I grew up in Northern California in the 1970s and 80s, and that at that time it was sort of peak Carl Sagan, you might say. Like it was like Cosmos on PBS, and it was fairly formative for me. And the notion that we are all star stuff and this sort of thing was definitely is definitely in my work and definitely informs this talk that I wanted to do. This idea that the stuff in stars is also the stuff in the soil and in our bodies, and you know, the same molecules in chemistry and different formations and structures. And so in the spirit of the interconnectedness of all things, I sort of wanted to connect the Earth and stars in this talk as the same matter. And maybe a simple, maybe not so simple softball to get the ball rolling is which came first, astronomy or geology? As a human impulse, which to look at the stars or to play in the dirt, which came first?
That's a great question. You know, you can look at it from different perspectives, but from a practical perspective, if you think of the need for people to build upon the earth, so that goes back to earliest times. But at the same time, I'm thinking people have always looked to the skies and saw so much more significance there. So I can't answer the question about which one comes first yet. They both reach back so far in time.
I would think that they were almost simultaneous awareness. As man became aware of his environment, those early nights, he became aware of the stars above. And his eye was the first telescope. And as he dug in the ground, he was, as we say in Hubble, looking deeper, digging deeper, and each foot that he dug into the ground, he went back in time because it was undisturbed Earth and the layering had been there over time. And so he was going back in time. As he looked at a star, he was seeing the light from the star that occurred many, many years earlier. The stars near us, it says the closest star would be 4 years away for the light to travel to us. And likewise, he was seeing. So I think in the first days of his consciousness, that early humans were doing astronomy as well as geology.
Picking up on your talk a little, Maurice, what do you, if we jump in 100 years from that glass negative that Hubble took at Mount Wilson to the James Webb, to a 2015 image of Andromeda taken by the Hubble Space Telescope, to now, what do you, and I saw you named a few future observatories that I'm not familiar with. What does the future of this technology look like?
Well, the James Webb is a telescope focused on pushing us through the very farthest distances that we can see in the universe, hopefully to the first light. The W-FIRST telescope will give us the ability to survey the entire sky. And to put that in perspective, Hubble used 7,000 pointings for the Andromeda galaxy. We hope to map the entire Andromeda galaxy with 2 observations with the W-FIRST telescope. And so looking at these objects with high resolution of Hubble or Webb and being able to capture them in a few observations or shorter exposure times with James Webb allows us to study a lot more features of the object. In the case of James Webb, these objects that were observed by Hubble will be measured much more precisely from a spectroscopy standpoint, looking at the spectrum of the object, of the light from the object. It will be much more precise, allowing us to date or place that object in the epochs of the universe.
It seems like, to go much beyond what you just described, we have to actually leave the planet. The James Webb is 1 million miles away, I think we established. So at a certain point, it's the only way to see further is to go further. Because this is still a sort of Earth-based observation. Atom plus 1 million miles. Did you freeze? Maurice? Marty, I'm going to ask you a question while that
Yes.
reboots.
The C.
Oh, there you are.
As well as the sensitivity.
We lost you for a second there, Maurice. Or maybe, yeah, I think we lost you. Right after my question.
Okay, let me see here. Is that okay?
Yeah, I can see you
Okay.
and hear you.
Yeah, so I don't know where I dropped off, but let me just quickly say the larger telescope allows us to gather more light. And so there's a sensitivity of detectors as well as the size of the aperture. The James Webb is at Lagrange 2, 1 million miles away, because it can cool the telescope much closer to absolute zero than the Hubble Space Telescope,
Wow.
which is at room temperature.
600 kilometers up in the atmosphere is room temperature?
So the Hubble Space Telescope operates at room temperature. And
I
it
see.
actually
Inside
has a
the.
very large temperature swing as it orbits in and out of direct sunlight.
Got it. Marty, I guess similar question for you, but I think in a way there's something so immutable about dirt and earth, and in a way I'm curious about what preceded the TBM. Like, how were the New York subways built?
Yeah, so as you can imagine, people dug with their hands, they dug with tools, they progressively dug, and then they realized as they're digging, it can collapse around. So the earlier types of tunnel boring machines were generally called a shield, which is just a can with an open end. You notice the pictures we showed, it's what we call a closed end.
Mm-hmm.
It only has little windows through which the soil is taken. In the old days, it was completely open. It was just a can being pressed into the ground, and then basically a backhoe in the middle digging out the soil. So push the can in, dig the soil, push the can, dig the soil. The problem with that is the soil knows you're coming because it's kind of collapsing in, the stress reduces in the ground. And so what do you see with the old process? You would see a little bit of settlement on the order of several inches of movement if you're lucky. And so you could measure and see the progress of the tunnel boring machine at the surface with this little trough that would develop on the ground as you're digging a hole. So that is very primitive, but at least it was safe, more or less safe for the workers, because the can held it from collapsing on them, but still the earth moved. So that was the older technology, which was used on the existing Red Line and the older tunnels in LA, as well as New York. And now, with the newer technology, it's just in the last few decades, it's really come into its own, which has enabled Los Angeles to really expand its subway program, because we can dig without the soil knowing and without the ground surface moving much at all. So it's come a long way in just a few decades.
It really does strike me like a giant earthworm. You know, it just goes through it eats dirt and poops it out the back. And sometimes you get these artifacts and anthropological remnants that it can't digest.
Yep, and it can be from as small as microscopic fossils to as large as on the regional connector, a whole steel beam coming through the machine. And it fortunately was able to do that without destroying the machine. It was able to continue, but yeah, a lot of stuff comes out of that machine.
When you say there's a microscopic fossil, how can it detect that?
Well, it's not that the machine would detect it, but if you have paleontologists or archaeologists on the back end examining the material that comes out the back, then with a microscope, etc. So people will take samples of it for different scientific purposes.
Are they riding on the train, these paleontologists? Or is this more like surface activity after the fact?
I think it's more surface activity generally.
So I'm imagining this science party on the
Yes, well, you can imagine how excited the various people get with it. It's, for instance, just think of when we had tunneling recently go through the La Brea tar pit area. They just excavated large blocks intact of that tar sand material, and it's being stored at or near the Page Museum, and it'll take decades to excavate through and see what's in it.
Wow.
So there's a lot of discoveries that are made because of our digging these tunnels.
With such a large deposit, can they trace a single thing back to a location, or is it a little bit more like this is a giant?
Good question. When it's blocks, like at the La Brea tar pits, a block like 3 foot by 3 foot, something like that, they pretty closely label.
It's flagged and so.
But if it's the material coming out the conveyor belt, they have a more general sense of where it's coming from.
Fascinating. What about seismic activity? How does that impact your work?
Oh yeah. So as I described, the entire Los Angeles area is subject to such extreme movements over time. And that's why the San Gabriel Mountains are moving up, the Santa Monica Mountains are moving down, and why we have the big plain where all the soils were deposited. I always tell people when they're concerned about earthquakes, well, do you like the weather here? The weather is because of the high mountains that ring Los Angeles, and the high mountains are because of the earthquakes. So if you like the weather, you like the earthquakes. My point in saying that is, yes, it's something to always be concerned about. So in the studies for all of the Los Angeles subways, you can imagine there's a lot of care to direct the tunnels and stations as much as possible away from hazards, and to design it so that people will remain safe. So the standard and the expectation is that everyone will be safe in the tunnels. And in general, underground is about the safest place you can be in an earthquake. The least safe is in a rickety building, right? But the safest is in a circular tunnels, like the Romans learned about arches. It's a good place to be. So yeah, I would not mind at all hiding underground in one of these stations if I knew an earthquake was coming.
Wow. Maurice, I was struck recently both by the web. You know, I knew this from the Hubble, but it was in the news a lot last week with the Webb. The way that the images that the HST puts out have been sort of artificially colored, but that coloring is a way of identifying the kinds of matter and the kinds of distance. It's a kind of coding for scientists to other scientists, which I found so interesting because I think a lot of artworks contain elements like that, codes and secrets.
So
they also happen to be beautiful for the public.
Yeah. So we humans use color to communicate, and with our eyes we see colors and they tell us things. So in visible light, we can determine that a piece of metal is hot because it's red, and that would tell us something. In the case of Hubble, it has the ability to see from ultraviolet through visible light range all the way to the infrared, to the near infrared. James Webb is about mid visible light range through the mid infrared range. And so we can't see the ultraviolet or the infrared. So we assign these false colors to the objects that we look at. And we have reference standards that we'll use for certain elements and assigning these colors. So that allows you to communicate hydrogen, oxygen, or nitrogen gas in a particular cloud by the colors that we use. And so you'll see false color conventions used across many nebula or stars. And in the case of these deep views, you'll see red being assigned to the oldest or the farthest away objects that are being observed in an image.
Mungo, we do have some questions that are populating the chat. So when you are ready, just let me know and I can.
Why don't we jump over to that?
All right. We have one question specifically for Maurice. Maurice, can you explain the relationship of space and geology? How did the Earth's elements arrive here? Is gold from stardust, nickel from asteroids?
So we are star stuff, but we are star stuff of at least a second generation star, meaning that the early stars were simply hydrogen fusing into helium. But the second generation star, after this first generation star goes supernova and has this massive nuclear reaction, it creates heavier elements. And these heavier elements, this carbon and oxygen and nitrogen, are formed. All the elements of the periodic table are formed during these supernova events. And so as that blows out into this cloud, like the Eagle Nebula, it becomes a place where you can gather up all of these elements into a clumpy little cloud. And as that cloud collapses, it becomes a second generation star of all of the elements in the periodic table. And so that's kind of how we get there. And then that gravity causes this, this matter to begin to spin into a spherical shape. And as it spins, it has a disk called a protoplanetary disk. And I showed you Fomalhaut as one of those stars that has a dusty disk around it. And that dusty disk is also all of this star stuff. And that star stuff begins to clump up into little planetoids. And these planetary chunks begin to spin and form up into spheres. And eventually they get to be big enough to be a full-size planet. Some of them become rocky bodies. Others will also gather up gas. And in the case of a Jupiter, they will become these giant gaseous planets with maybe a metallic core, but mostly layers of cooled gas that are around them. And so those two principal formations of planets, and hopefully they live in a neighborhood where there are not other large objects like in Fomalhaut that cause these crashes and prevent them from forming up into a solar system.
Wow, that was such a great description of so much bigger than us. We have a question to Marty. What's some of the wildest stuff that's come through?
I was going to ask that.
Celine beat you to it.
Yeah, so that steel beam that's come through, that's for sure. Some different fossils, as we've described. And so in excavations for Metro, you have everything from large mammals that lived on the ground, right, like you see at the Page Museum, to all the marine mammals and things like whales and other large marine mammals. So those are paleontologically some of the unusual things that have come through. And then geologically, you find fascinating things also. You have petroleum deposits come through, crude oil coming in, if you can imagine that. You have gases associated with that that are coming in. You have hard rocks, sometimes so hard, it's hard to chip with a hammer, and sometimes so soft, it just goes right through. So geologically, the range of materials we see is extraordinary, if that helps answer it.
Moving back into the cosmos, we have Gregory asking, what is the width of the cylinder of space into which the Webb telescope is peering?
Let's see, how would I say that? But it's measured in arc seconds. And so if you think of an eye of a needle, or eye of a needle would be a good example. So if you could extend this eye of a needle, say have a friend across the room, and you peer through this eye of a needle, is about the aperture that the James Webb or the Hubble Space Telescope is peering through. And so you see the observations that I showed of a deep view the size of the moon, that is, I believe, about 6,000 different observation areas that were put together to make this cover an area the size of the moon. So it's a pretty small patch of sky.
We have a question from Connor. It seems like the third machine in the project is conceptual art. Can Mungo talk more about what is being discovered by this conceptual art machine? I'm also interested in if Marty and Maurice have any layman questions about conceptual art.
Oh, that's great. Yeah, I'm curious about that too. I don't know that is anything being discovered. I think in a way I wanted to convene this talk precisely because, I mentioned National Geographic and Carl Sagan. I've always had this sort of interest in this realm, but no skill for it, and a skill for this other thing. So I'm definitely this right brain person who sometimes wonders what it's like over there. And in a way, I spend all my time asking questions like, what would happen if, and it doesn't matter if it fails, or doesn't matter if there's no result, or if it solves or proves anything. But sometimes, philosophically speaking, it's nice to talk to people who actually take these questions and chop them up and sort of turn them into measurable fact. I think in my field, there's not a great deal of measurable fact, and it's part of what I love about it, but it's nice to step outside it sometimes.
I think in my time at NASA, that my work with data visualizers, the people who actually take the raw observations from Hubble or the satellite data from the satellites peering down at the Earth and give them color and some additional texture, not changing the information, but providing colors and tones that artists bring to the subject, allows scientists to discover phenomena and features that they conceptually knew existed on a mathematical level, but they begin to visualize what it actually looks like through the hand and eye of their artist or visualizer. And I've seen that happen a number of times where the scientist actually says, wow, instead of the artist saying, wow.
I have a question along those lines, Mungo, and that is, it's such a fascinating conglomeration of the beauty of the natural world with the conceptual and the thinking and the concepts that go along with it. So my question for you is, as a patron of the subway walking in, what is your artist's intention for people more? Is to be drawn into the conceptual world or amazed by the beauty of the natural space?
I don't really have a preference, or what I would say is I try to make things that function at different levels and different kinds of legibility. And it's pretty important to me that art not be super rarefied and inaccessible. At the same time, I sort of want to defend my right to be opaque if I want to be, So I think I want to make things that are visually compelling and enough to make you interested, and then you can enter into their complexities. But if you stop just at these, oh, that's pretty, that's totally okay with me. So I don't know if that answers your question, but that's
yes,
for,
yes.
you know,
It's multi-layered in the
yeah,
conceptually in the same way that space and the visualization is multi-layered going back and digging into the down. So the very art is multi-layered.
Yeah, right.
So related, Gregory had a second question / comment. Every point of light in the sky that is a star is coming from a particular past year, many of them hundreds and thousands of years past. How cool if we could look up at the sky and see these points of light's distance in light years rendered as year dates. Thoughts?
This is maybe back to what I said before, Maurice, scientists can read how old those stars are in those photos.
Yes.
Because they speak that language.
Yeah, the spectra analysis of a star allows us to determine the distance and the age of the star. And yes, it would be really nice to be able to look up and kind of see a little tag to tell you how old the star is. And James Webb will perform that function on some stars that Hubble has seen and hold up as the most distant stars that humans have seen in the universe. And of course, James Webb will search for older stars closer to the beginning of the universe after the Big Bang. But it will also be kind of the speed police to tell us how far and how fast these particular objects have been traveling.
In a phone app? Asks Gregory. That's what they're looking for. All right, we have a question from Eric, and it looks like it may be one of our last. Considering, well, we have many questions keep popping in. We'll see what we can get to. Considering the spectral capabilities that are now receiving data in the James Webb system, what news might we learn about, oh, this is very dense, nucleosynthesis, creation of the nuclides and periodic table? And might this be artworthy?
The second part I'll try to tackle by saying the first challenge will be for a visualizer and a scientist, astronomer, to visualize this new discovery. And I believe the question is asking about James Webb's capability, just like Hubble, to rewrite the textbooks and to give us new questions that we didn't know to ask before about the formation of the universe. And there is some physics that's in question today around the expansion rate of the universe. And this spectral analysis will raise some questions that we did not know to ask. And it may point us to some phenomena that we have not been aware of yet. And we will hope that artists and visualizers will help us, ordinary folk like me, truly understand what these phenomena are when they are discovered.
Great. Let's see, we have a couple more questions. Mungo, are you good with us taking just a couple more from the chat?
Sure.
From the Q&A? Great. They're good ones. This is from Destiny. Question for all speakers. How have the latest James Webb photos inspired each of you in your respective fields?
I can answer that. I guess I think what we saw last week with everybody sort of freaking out about those photos, I think was sort of a mass encounter with the sublime. And I think, you know, the sublime is the aim of a lot of art, and that is to produce an encounter with phenomena of scale that awes and humbles you. And to me, the timing was good for this talk because it felt like it's definitely a realm of interest for me, clearly. But it was interesting to see, you know, people crying on the news and stuff. You know, it's like like I said, I thought it was sort of a mass encounter with the sublime. So I wouldn't say I necessarily have a place to take that, but I quickly checked that, you know, the FYI, these negative space projects that I do, the Hubble encourages use. The taxpayer pays for the Hubble, so the photographs that they have available on their website are free to download and copyright free. They like to be credited, and I just checked that the James Webb goes by the same principles. So there's a good chance that I'll make some negative space murals with James Webb images in the future.
For me to answer, it's one thing that's interesting is I really appreciate we as a society accomplishing things together. To me, it represents the positive in humanity, which we need more of.
Well said.
I think there are two things that the excitement of the new releases mean to me. One is to make sure that as many people as I can possibly touch appreciate the uniqueness of our place in this beautiful universe as we see it in new ways. And the second is a little bit harder edged, is that these times that we're in, that we better understand how precious this little blue marble is, and how we are responsible for taking care of this little blue marble. Because as we peer out into the universe, we look at 5,000 exoplanets so far, and we have not found a one that is like this little blue marble. And so trying to convince us all how important it is to preserve and protect and care for this little blue marble is my new motivation.
That
All right,
seems like a good place to stop, but you want to keep going?
No, that works. That works. That does seem like a good place to stop. And for the speakers, just note the Q&A, and if you want to answer any of the outstanding questions, feel free, so folks can stay on. Mungo, do you want to close us out?
I'd just like to thank you, Marty and Maurice, so much for such an interesting talk. That was everything I could have hoped for. And Letitia and Carlin, thank you for making it happen. And yeah, LA Metro, thank you.
Thank you for inviting me.
Thank you all very much. It's fascinating. It's very positive. It's nice progress.
Thank you to all the attendees.
All right then.
Take care, everyone.
Bye, y'all. Take care.
Bye-bye.